Welcome back to Demo RPG. We're now up to episode 16, and we're kind of at the point where our library is somewhat developed enough to actually, start writing a real game if we want. I guess, technically we could have done that a long time ago, but we were sorting out some final systems and sorting out some tests just to ensure that everything works correctly. And this was just some essentials that I think people should know about when they're developing their own application. But now, as we're getting near the end of this series, well, there's really no way we're putting in enough time to make a fully fledged game, because ideally this would be, some actual RPG you could play through, but that we're only putting in like maybe 20 hours into this. A real game, of course, takes hundreds, potentially thousands of hours, but we can at least hack something together quickly as a demo, which is basically what we're doing. But rather than keep adding to the library at this point, let's go ahead and make an implementation of the library and start building a little game. So what we're going to do is just at the top of our solution, I'm going to collapse these little guys, top of the solution, right click and just go add, new project, and we need to basically decide what we're going to do. Let's just go with empty project for now. Hit next. And let's just call this, we're just going to call this RPG prototype. This one is an actual, if we go to properties, we'll see it's an actual application. So it runs as an executable, basically. And that's fine for now. And now we got to make more design decisions. Let's go ahead and do show all files. And let's give it a main. The main, of course, is the entry point. And let's go ahead and also right click on it and go to add reference demo RPG, because that's the library we're going to use. And then we should be able to include the demo RPG stuff. Demo RPG, but it doesn't see it because we have the path to the includes, but we can just make sure you're on all config, all platforms. Yeah, we can put the includes on this include directory part. I guess we could do it either way. You can go under C++ and put it under additional include directories, or the VCC directories and put it under include. But basically what you want here, well, since they're in the same solution, you can just go, yeah, normally you click this and go to edit, but you can type it in there directly. I guess we'll show it this way. Click the little new line and then go $, open parentheses, solution, dir, like that. And that'll get you to the root of this demo RPG. But then we want to go into demo RPG itself and then into include. In the solution dir already has a trailing slash, so you don't need it. And once you click somewhere, you can see it lock in and it'll tell you the value it's given. And that's fine. Looks like we want the other slash here just to keep it similar to the others. But basically this will get us to that include dir. And yeah, it's demo RPGs twice in a row because that's what we named the top level project. And that's also, oops, let me just open this in a folder view so you can see just in case. So yeah, I have my source, lots of stuff here, demo RPG. And then there's this demo RPG here, which is the library that we were building. And it has the include, so that's why we gotta have demo RPG twice. But now within the project, we also have the systems unit test and the prototype. And that's pretty much it. So now we should be able to start including stuff. But what do we want to do here? We should see that we basically got to go into demo RPG yet again, just so that we can tell what this include is coming from. And we just got to start actually using stuff in here, like monster, for example. And there we go, it's happy. So now, let's make a main here. You can pass arguments into a starting application with the argc, argv stuff, which looks like int c, or int argv is the count, of course, and char star, double star is argv, which is the character array. This is a double character array. This basically means it's a whole bunch of different lines of text, essentially. And well, now you can go from here. You got to decide what you want your game to do. Most notably, what you're going to want to do is have a while loop, and you're going to have it do stuff while the game is running. So let's just make a boolean up here called running, set it to true, and we'll just say while running. This might be really common knowledge to you, but I'm assuming that whoever's watching this might be really new. So basically, you perform your logic, and you just, you know, when you want to exit, you set this to false. You have all your exit stuff down here, and that's basically the gist of it. So we basically have this sort of thing to work with. Now we're probably going to want some stuff. There's a couple different ways of typically running an application like this. Sometimes you wait for user input and then you update things, or sometimes you have time passing and you update periodically every so often whenever you decide you need to update. It might be once per frame if you're running a application that has graphics just as fast as your computer can go, but usually you want your logic and your physics locked at some set time because you don't want it to update way too fast or too slow, so you just say, hey, update once a second or something like that. Oh, design decisions. So sure, we can make a loop where, you know, we generate a main character, or you pick a main character, then you do stuff, and maybe we'll show that. But we just really have to decide how we're going to visualize this. Now we could just use the console. That's probably the easiest way. So I'm going to set this as the startup project, and let's just run it. And we'll see that, well, it's basically going to get stuck in this infinite loop here because we never exit the while loop. So it's just going to sit here like so, updating a million times per second. And sure, we could visualize it by just going something like update. And we see that every time. Let's go ahead and include IO stream for now. And we should probably have a return 0 at the end, or exit success. However you want to do it's probably just fine. Oh, that's the wrong word. See out. There we go. Or you can use printf or whatever you want. It's fine. So if we hit play here, we'll see that it basically just updates super fast endlessly. You can see it scrolling down here. And while there's nothing particularly wrong with this other than it doesn't really do anything useful, it's a pretty standard setup for getting into your main game loop, and it just does your game logic in this while loop until you're done. So we need to establish basically some kind of game loop, and then some kind of exit condition, which is usually just quitting the game or something like that. But let's go off on a little side tangent for just a few minutes and just research basically how we could visualize our game if we wanted to, because here we go. We're into just another area where we've got to decide. So I'm just going to do a quick Google search of C++ game libraries. C++ game libraries. Sure, there we go. And we'll see that there's just a ton of stuff. Of course, you know, I'm making my own, the one called Ancient Archer, and we could in theory even just use that. Maybe I'll end up doing that. But, you know, there's just so much stuff. Here we go. Here's someone that put together a little list on GitHub. Mainly right now we're kind of looking at rendering. We basically just need a way to visualize, which is rendering essentially. So we'll look at rendering and we'll see that there's all of these, and this is probably, oh my gosh, okay, this is not all of them. There are a ton more. So basically we have to decide, all right, what libraries do we want to include? And I'm going to go with none. All right, so if we're going to use a console to do all our showing, we probably want to clear screen. And I don't know if I'm going to stick with this method, but I at least want to show you it because it's kind of handy in a pinch as a visual update system. So we might as well at least show it. All right, so let's do a few basic things here. Let's make a map that we want to draw, and let's make a little system where we can move a character around. So we'll start out with that, and we're just going to use a vector. Or now let's use a character array, and let's just make a 10 by 10 grid that you can move around into, and we'll make it a little bit bigger. We'll make it 12 by 12 so that we can have some edges, but we'll have a 10 by 10 area that we can move around into. So our map's going to look something like this. And the reason it has to look like this, well, it's 12 by 12. If they're 12 characters, well, there's a hidden final character that is basically a null character to tell it to end the string or end the char array. So it has to be 13 if we want 12. Otherwise, like if we try to make it 12, we put 12. There's 12 different things in here, 12 different exits. And it's an error because it's too big. It actually goes to 13 even though it looks like 12. I know, that's confusing and makes absolutely no sense. But it's just the way that it is. And it's just, there's a final null character. It looks like this. So, yeah, that's the null character to tell it that it's at the end. So yeah, that's just the way that these characters work. But essentially, we can turn this here into a map. So we'll make those little small X's the border, or we could select them all using the power of Shift, Alt, and arrow keys. In case you don't know about that, it will save your life and your carpal tunnel. And we can go Control U. I think it's Control or Control KU. I don't know. There's something uppercase. Maybe it only. All right. So now, as our update goes, we can draw it. So taking input is where things get confusing, because we either need to check for hotkeys being pressed, or we need to take a CN from the console line for the next action. And we can't exactly do a live game while taking in console input. We can go char C equals get char and wait for an entry press, and then we could update the map. So we can make a little function called show map. And maybe we do this all globally. So up here, let's go void, show map. And let's just put the map up here globally as well, so anyone can edit it. It's not constant or anything, so anyone can change it, but it's always the same size. So show map is just going to go through a loop, and I equals 0, I is less 12. And then we'll put an inner loop. We'll just call it J. 0, J is less than 13, J++ on this one, otherwise we're going to have some interesting happenings. All right, so basically for each one of these, we're just going to spit out the map that is at I and J. Now you can do it like, I think you can do it like that. I don't know, that might work in some standards, but usually it's actually like this. And then when we're going to the next line, of course, we just want to put a new line here. Let's make a new line character. It looks like we're going to need some brackets on this loop too. All right, that looks really messy. Let's hit our auto format. Okay, so anytime we call show map, it should essentially show this map. Now we can do another trick here, because they're going to somewhat overlap eventually, and the maps are going to, that's just going to be a console of a bunch of different maps in a row. So we can go system, I think it's clear. We can go system clear to call it clear screen. I think that works, so we'll try it. So now we can say anytime we press a character, basically show the map. Now why is it anytime we press a character? Because get char waits for a character entry. So yeah, it's going to keep doing this loop, but it's going to keep stopping at this get char and see what you press. And then when you press something, it'll continue on, show the map, flip back through the while loop, and wait for another character. So maybe we should have something here that says like, I don't know, start it with a new line, press enter or something. That might be just fine, actually. And let's see what that does. So let's go ahead and just run this. Press enter, okay. Okay, it says clear is not recognized. Maybe we need to sort that out. Is it clear screen, maybe? I don't know. It's one of those, but lo and behold, once again, even if I don't tell you the exact thing, you can figure it out. Yeah, clear screen is not recognized by just doing a Google search. System clear screen C++. All right, that easy. And you'll find some answers on it. Looks like it's CLS. Okay, so capital CLS. Let's see if that actually works. And so basically, it should clear the screen and not keep filling up things. Now, this is a really slow method and typically not recommended. So take that for what you will, but it's a way to do it. And now, as you can see, our console doesn't have, it basically, it's 12. This is 12 by 12 map, but it's way taller than it is wide. And that's just based on your console. One of the things you can do is you can go to your properties and you can change your fonts and look for a monospace font, and that might help. But the new lines are probably going to be taller than every character. And there's color options here. Yeah, your terminal is going to be different, of course, depending on which one you're using. But I don't really see anything that lets us change the line height. Window size, window position, meh. Yeah, don't really see anything. Another thing that's super important to know, you might not know this, at least on Windows command line, is if you click inside of here, you go into a mode called select, and it says select up here. You might already know this, but when you're in this mode, your program stops updating. Like, sure, it says it's going and everything, but it's not actually going to do anything. If we press enter, it goes out of select mode, or you can press escape to get out of select mode. But select mode is a mode where it's like ready to copy text, basically, so you can hit things like Control C. So just FYI, select mode is a thing sometimes. If your program's not updating or not continuing, sometimes you're in select mode in your console and you need to get out of it. Just a Windows thing. And now we could develop a system where this get character actually takes some kind of character that processes an update, for example. So this is a way, if you don't want it to continuously update and you only want it to update the map when you press a key, or update your character when you press a key, you can give it commands like this. And sure, that works in a hack and maybe for a text-only program that waits for user input before continuing. So let's go ahead and make that sort of system real quick. Let's make, how are we going to do this? Let's make a player area. All right, so let's just go character. Actually, let's make this a struct, because the player is going to have a position, and we'll make this an integer. I'll make X pause and Y pause, and we'll make maybe facing. We could make like a facing direction. I don't know. Let's not worry about facing direction. That kind of gets too complicated, so we're not going to care about that right now. But we just want an X pause and a Y pause, and we basically want to keep them on the map. So they need to be basically between or in these blank areas only. So we'll decide what else the character might need here in a second, but let's just go ahead and get them moving around a little bit. So, and we can look this up once again. Arrow keys character C++. Here we go. Yes, yeah, once again, back to the old Google, and we can see that they're going to have some special stuff. Looks like they just have some characters you can designate them to, but there's probably a better way. Yeah, I guess you can do it with these defines. Sure, let's just do this. So let's just copy this code here, put it up here, or anywhere, I guess, really. And we should be able to take it from there. Let's see, what do? They just do this get character here. So we can copy that, sure. Oops, not here. But basically, for this get character, we can just go something like this. We got get character in the switch, which is going to check what it is. I'm going to use get char. That might have been a Linux thing, so it might be a little different in Linux or whatever. But basically, now we can have an up, down, left, right, all these different directions, and it'll do nothing otherwise. Well, we can now say we can basically keep track of a player on the map. So we can basically update the map before we show the map, like so. And we want to keep track of the player position because that would make sense. So this is going to get more complicated as we go, but you just have to think about every little logical thing. We should probably call this a thing, like a player. As you can see, we haven't even used our library yet, but we will, or we could at any point. We just want to get a way to show them on the map, because I was thinking here, basically we're going to get a player on the map, we'll get a monster on the map, and maybe we'll have you walk up to them and then start a battle, and that'll be enough for this particular episode to at least give you like an example of how you could do it. But you know, this is really pretty ghetto of an example. Void update map. So we just need to decide what we do here. How do we update it? We probably want to update it with the player position. So maybe we want to actually hold a previous X pause and a previous Y pause as well, just to know where they came from. If they're going, you know, a different direction, we want to know where they were before. Okay, so how are we going to update the map here? Let's just say wherever the player is, let's just draw a P in that location. And we'll just say if, let's see, the map at X pause, Y pause. Well, we need player here. Let's actually instantiate it. There we go. Now we got a global player. Maybe we'll just call it player 1. Because, I don't know, if we start feeling real fancy, maybe we could add some multiplayer and some networking, but I don't think we're going to have time for that unless a bunch of people sign up to the Patreon or something. Otherwise, we're probably just not going to have time for that kind of thing. All right. So, there we go. And we need to check this against some. If it is not equal to an X character, because the X's are walls, then we'll add them to it. We'll just say the map at that position equals, we'll make it a capital P. And what about the old position where it was? We need to update this map in total. So we need to handle the previous position too. So we would have to say something like the previous and other previous here. Much copy, paste, there we go. We'll just set this to blank. And now we need to finalize and just update these positions. So basically we're going to have to say, well, now the previous position is the current position. Basically update for next move. And same thing with Y pause here. If you think about it, it'll make sense. I'll leave a few comments in here just to make sure it makes as much sense as possible. Check that the player hasn't moved to a wall. Alright, so that's the first thing. And if they didn't, that's the not equals here, if they didn't move into the wall, draw the character at new location, make old location a lactation. What's on my mind? Make old location a blank area, and then update current location to be previous before next update. There we go. So that's basically it. Now we also want to handle this case right here of the else case. What if they are moving into a wall? Well, in that case, we just want to say that they didn't move. Basically, we want to set them back to the previous location. So it would look like this, except in reverse. Because based on the way that this is updating, so if they do move, you know, we're holding their previous location, and if they try to move again and they move into walls, we're just going to set them back to where they already were. That way you just can't move into walls. So there's some pretty straightforward logic to just update the map based on the player location and not let them move into the walls, and we're going to draw P wherever they are. So the way we want to move them is based on this get character. If they move up, we'll just move them up. We'll just say player1.xpos. Let's see. Now we got to think about this. It's going to be a little confusing maybe. But basically, we got to think of this at the top left as 0, 0, and down here as, I guess it would be 12, 13, or 11, 13. I don't know. Something like that. But basically, this should work without us having to really overanalyze that. But if they go up, X is going to go minus, minus. If they go down, wait, let's think about this. See, X is going to be this one here, and that is going to be which row, basically. And this one is how far along the row, or which column. So it's kind of a row column setup. So X being the row, yeah, it's going to be plus or minus going up or down the rows. And if you go left, of course, you can imagine what this is. It's just the Y pause, minus, minus, and plus, plus to move right or advance along. And if you press any other key, it's going to do nothing at all. And another thing we want to do here that is going to be maybe a little weird here. But basically, after we get character, we want to clear the IO stream, because the input stream could have a bunch of junk data in it if you're just spamming keys. So basically, we want to do a cn.ignore. I guess this would be standard. And then we say till what, or what's the stream size. We'll say up to 100 characters or to a new line. Now, basically, that's just going to ignore any further entry beyond this character up to a new line. And yeah, that should just help produce some input errors potentially. Then we call update map, which is going to also handle moving the player, or maybe we should call this like move player. So let's just call this move player on map. It's probably a better name. Move player on map, and then show map, and then start all over again. Now let's go ahead and take a look at what this does. Let's see if this works as expected. Press enter. Okay, well, our characters, we don't have an initial position, so that's kind of an issue here. Let's make the initial position 3, 3, and 3. So let's start somewhere near the middle here. We need some initial positions here too. All right, that's should work a little bit better. We should actually see him on the map. Oh, and now that we're ignoring this new line, this didn't quite work as I expected. Now that we're ignoring this new line, it's actually, we have to press enter twice, so that's a little awkward, but let's just take that out for now. And while we're moving around, it's not really doing what we expect. It's not updating the map, it's not drawing, and we have to analyze why. It's possible that this switch statement is not working correct, because I don't know if, oh, this is just kind of wrong too. We should get the character and then check what C is. So just, this should make a lot more sense. What is it doing? Oh, it's at the stopping point again. All right, let's just see what it does. Why don't we just put stopping points at all these cases and see if it actually hits any. That way it just lets us continue doing stuff until... Yeah, so these scan codes are not correct for these arrow keys. It's basically what it comes down to. So what are we supposed to do about that? Well, we can just do a literal check for what these are. Yeah, that's probably going to be better. Okay, what if we just forget about all these for a second? Let's just go like this. See out. Oh, it's hitting clear screen. So that's kind of messing it up. Let's put it at the bottom of the show map here. There we go. So now it should clear it as soon as it displays it, because that doesn't work. And it basically just says it's always C. Oh, that's because we're not too bright. We need the actual C variable, not the character C. All right, and it's displaying nothing for the arrows. So they are some internal code. Maybe we need to display that. Okay, well, it's possible that, well, that this is just not something you can do. It looks like we do have an answer here. There's no standard way to process special keys, console, output, C++. We simply can't display it. Maybe we just use something other than the arrow keys. All right, this is becoming a nightmare with the arrow keys. So let's just forget about it. And let's just use ASDF. Okay, W's up, S is down, A is left, D is right. Okay, let's just do that. And this should actually work. With any luck. Okay, well, the player is showing momentarily and then they're disappearing. So we're closer. But you might notice we have to press enter every time after this get care, and that's actually kind of annoying, but yeah, that's why nobody typically uses these consoles, or they use some special thing to process it quicker. Okay, these don't work. We're not using string. Oh, we're calling this move player too often is the problem. Yeah, we're just calling this move player too often, and it's just constantly doing this stuff, which we don't want it to do. So that's fine. We just want to do another check to make sure they're not the same, basically. So let's just put an and here and go player1 dot xpos not equal to player1 dot previous xpos, or now we need to put these parentheses together. So we need to check all the things at once. So we just don't want to update things unless the player actually moved. So yeah, we want to check that they're not moving into a wall and that they're not in the same location that they're already in, because we don't need to process updates in that case. In fact, we don't need to do anything in this case, so we could just go like this and just return if that's the case. Because we just, you know, there's no work to do if they haven't moved. So let's just do that. That should simplify a little bit. If they haven't moved, turn and do nothing. Otherwise, we process their updates. Okay, well, let's try that. Oh, it's ASDF, right. Yeah, it's not working still. Are we running into this case yet again all the time? Or is it one of these that's messed up? Let's actually place the player on the map to begin with. Guess that makes sense. X pause, Y pause, equals capital P. That way we should at least show them to begin with. We should probably show the map to begin with. Let's forget about this press enter thing. Let's instead put move with lost. That way the player knows what to do to some extent. Okay. What's going on? Oh, we hit a breakpoint. Okay, so it's actually hitting the breakpoints. That's fine. That's good. All right. Why isn't the player moving now? This is some real annoyance. Why is the player not moving? Oh, because of this. I guess we gotta majorly rethink this logic for days. Okay. No, we don't want an OR case here. We need an ANX. Both of these need to be true. You know, we need these to be... Okay, this logic was just wrong. So it was just returning every time and never moved. So if the X pause and the Y pause are the same, they haven't moved, do nothing. Okay. Yeah, now it should work. Let's move right, move right, move right. Yeah, there we go. Hit a wall, doesn't let us go right. Let's go down. We got to hit enter in between every move, but at least it works. And we have a player moving around the map. So what next? Okay, well let's bring in our library and actually do a few things. We got monster. Let's also include, well, let's just include player character. All right, and let's give this player character an actual player. Player character us, and we'll just make it default construct to whatever we want. Now we have to fill it out with something. This is probably going to be a compiler error. Let's have a check. Yeah, because it's attempting. If we look at our error here, bring it over a second, attempting a deleted function. So now what we have to do is instantiate it as something. So maybe we wouldn't actually do anything with this till we bring it in. So we go with something like player. We'd have to take a player character delegate star here class, we'll call it, and we delete all the other ones. And we could say that this is going to be, or wait, it's going to be us rather. Go us with care class. There. And now we'd be able to access all of that. And we need to instantiate player 1 somewhere, and we probably need to put this in here. So we'll pass it in like so. And I guess we want to do it by reference. In this case, const reference probably. No, we can't do it by const reference. It's got to edit the actual player, so it needs a reference to the player. All right, so let's make our character. So what we can do here is we can do something cool. We can go choose a class. And then we can give them some options here. Like, we'll say 1 for cleric. How are we going to do this? I guess we'll just do a couple spaces here. 2. Yeah. 1. I don't know. We'll try to make it as clear as possible. 1 equals cleric. 2 equals warrior. Let me break a new line here. 3 is rogue, and 4 is wizard. All right, and we just wait for character input. We can just go, yeah, that should be fine there. We could just go cn. Oh, let's do a string here. Or I guess we could do a multiple different things. Let's use string just because it's easier. Call it choice. All right, now let's do an integer. And choice equals, yeah, we use get char, and we'll say, we'll do this a little differently. All right, we gotta make some decisions here. Int choice equals, we'll just say start it out as 0, and we'll say while choice equals 0, we'll ask for the selection base. Now you might think, what if they enter in a non-zero? It's going to continue on. Well, we can just go something. We can just say that if, I don't know, we'll just lock it in place basically. If choice is less than 1, or if choice is greater than 5 or 4. Yes, those are all invalid. And we'll just set choice to 0. That way it continues the loop. Otherwise, we'll continue on. And we'll just go, let's go ahead and make this player somewhere. Let's make the player a pointer. All right, let's go. And that's just so it doesn't instantiate right away. Call it main character. Make it a point. So it's just going to be a null pointer first. It's global here, so anyone can access it. And then we can just switch on this choice. Switch on choice, case 0. We'll say main character equals new main character with a new, what is 0? 0 is cleric, new cleric. And it doesn't know what that is. So we just need to include all those classes here. And I think we have a all-in-one header that we made just for this case. Yeah, playable classes forward. Playable classes forward. That way it just includes all of them at once. Okay, so here we are. This is new player character. And does that work? It wants a pointer to a PC type. So yeah, this has got to be new cleric. Why it doesn't like this, I don't know. Guess we're gonna have to find out. Right here, and just put all these other cases in here. They're essentially going to be the same. Let's just do some copy pasta action with Control D. Just update these accordingly. This last one should be default. Probably would just want to throw an error. So we'll return like -20. Failed to make player character. New warrior there. Rogue here. And new wizard here. Now I think the problem with this is these need to be scoped because we're creating variables. So let's just go ahead and do that. Put them in their own scope for each of these cases. I think that's the case because we're using new warrior and stuff like that in here. Don't exactly know why it's complaining. We'll figure it out in a second. Switch statements seem to work differently in every language. Hit the formatting key. Okay, so what's this problem here? Not be designed in entity type player. Oh, okay. So we need to call this just player. It's our new struct that we made here, up here, this one right here. And that delegates out this player character once again further. Let's see if that's gonna work correctly. Yeah, because that's gonna take this pointer and instantiate it with that pointer once again. Let's just see if this works. We got to change all these to main character, and in this case it's something like this. Update the map there to start, and now these are all pointers as well, but then this is also main character. So we can just change, we can just do a select update here, say this is now main character, but we want to get we don't want to update this move player. That's got its own thing going on. Just these three. And we want to pass in the main character here. But it wants a reference to it. So we need to dereference the point. Now we'll have a reference to it. And if we have any null pointer errors, we will get some crashes. But we shouldn't have any. This should be pretty fully defined. Compiles correctly. Choose a class. Let's choose cleric. And see what it does. Looks like it's not doing anything. Why not? So what's happening here is it's evaluating this as a character, not a number. So get character only gets characters, it doesn't get numbers. Let's go like this. Let's just pipe it in. See if it's happy with that. Let's try to actually pick a class. Okay, let us pick a class. Now it did a clear screen before we actually got to see all the stuff. But it looks like it did get through instantiating the character and everything. So now we do have a character. So basically what we want to do at this point is in our little update thing, we probably want to go through some turns. Because, you know, we got the player set up now. We can actually do stuff with him. We're moving forward, using our library. This is a good sign, fellas. It's a good sign. But we need to decide what our game is going to do at this point. And of course, the options are really endless. So naturally, we have hit points. Let's just fight something. Let's just put a monster at a random location and run into him and then battle him. That should be fine. Now we already know what a monster is. We've got it included. Let's just make the monster somewhere. We'll just make it global for now, but really we probably want a generator of some sort. Baddie. We'll just call it Baddie. And if we go look at monster, we'll see its default values. It's got nothing. It's not even going to allow this to compile because monster's deleted. We at least need to give it HP and some damage. That's all it really needs for now. So we'll just go ahead and put that in here. Let's say it's got 10 HP and it does 1 to 3 damage per attack. And that should be good enough to get started. Maybe we'll just, it needs a location and stuff too, kind of like the player has a location. But we can just hack that for the moment. Let's go ahead and make it a struct. Monster, sure. Or we'll call it like, I don't know. I just want to, I'm tired of naming stuff. I'm tired of making design decisions. I'd rather just have all that ready to go and program something personally. So, I don't know. I could probably use a job where the design is already done and I just need to instantiate it. That would be great, but that's not what's happening right now. So, we got to come up with a name. Struct. Sure, we'll just call it a fightable because we got to call it something. We'll put a monster in here, give them those default values. Let's give them a position. And there we go. Let's make a constructor. Let's take HP, min, max, just for damage, and instantiate this monster as so. Forward it as fast as possible, basically. There we go. Let's delete the default constructor. Now we got a way where we can factory these out. Just make a fightable, give them all the stuff, and we should be able to take it from there. So let's just maybe, at the beginning of the game, let's just, we place the character on the map wherever he is, but let's randomly place the monster somewhere. Now we do have this random in demo RPG, so we could just use that to put him in a random location. Why not? So let's just go, let's see, we got this guy. Let's put it above the main. We probably want to put most of this stuff in a .h file just to clean up everything, ideally, but it's fine for now. A giant main, there's nothing wrong with having a giant main. Maybe we'll just have one monster at a time. Current monster. So we'll just come up with a little system here where basically you fight monsters over and over. Maybe like a little arena type battle, where every time one monster dies, a new random one gets created. You fight it, you loot it, you fight the next one, you loot it, and you just see how long you can last. Maybe we need an XP worth. So XP worth, we'll start it at, I don't know, probably give it a random value. Or no, what if we calculate this? We'll start it at 0, sure. But what if we say its XP worth is going to be HP plus min plus max, all of that times 2. All right, so there we go. We just get it worth an amount of XP that ends up being determined by how powerful it is. Just a little random system to get started. There we go. So it's actually worth something, and we can give our player XP. Just a little random system I came up with. Nothing too big there. Too many parentheses, really. There we go. That's fine. Okay, so now let's go ahead and make a little system. We'll just do maybe current monster. Well, wait, we already have a monster, right? We have current monster globally here. And we'll just start it out as something equals new current monster. And we'll take some random values here. So in demo, we need to include our random from demo RPG, the one that we built. What did we name it? We named it random. Now the only random function in here, of course, is the n to k random, which returns unsigned ints, but we can work with it. That's fine. It just means we can't random negative values, which we don't want to do anyway. So, okay, so let's do this current monster here. Maybe we'll do it for the map placements. And we'll just get some random values. So that is in namespace random, int k, and we'll give it some HP somewhere between 5 and 10. We'll give it a min attack of 1, max attack of random, int k. Maybe it can be somewhere between 2 and 4. So there we go. A little random monster generation there. Doesn't like this for some reason. Oh, we spelled random wrong. That's probably why. Expected a type specifier. Oh, it's just, what do we call this? Fightable, I think. Not be assigned the type monster. Oh, so this needs to be, right, fightable. The one we're composing here. Okay, so the current monster is going to be a new fightable. We'll give it some random health and some random damage. Now, we could base this off the player's current level every time. So we could make a function to do all that, which we might later. We'll just have this as the starting out one. Let's nerf him a little bit. He might be a little too strong. Maybe he even does less damage. Yeah, let's just nerf this first monster into the ground. He's just got to be weaker. They got to be able to like guaranteed beat him. Otherwise, it's gonna be a crapshoot. So there we go. And he needs a location. So let's go current monster. Xpos equals something. Maybe we'll just put him at like 7. And the ypos is 7, sure. So we'll just kind of make him on the other side of the map. Or maybe we'll even make him further down, like 13. No, not 13. That's not going to work. 10, 10. That should be at the bottom right. And we'll update the map with the monster. Kind of the same way we did player. Except we'll make the monster an M. And then we'll show map. And then we'll do a while running. Let's just make sure this new monster actually shows on the map. And there's no compile errors. Looks good. Okay, let's choose wizard this time. Oh, we got a crash or something. What happened here? Okay, I'm going to look at this debug. Let's look at, okay, the build succeeded. -12. So it failed to make the character. Now, why would it do that? Don't know. Oh, it's because we have these cases messed up. Should be 1, 2, 3, 4. That'll do it. 0 is invalid. All right, let's try that again. Choose wizard. Let's move. Now, what we could do is we could say, okay, maybe move to a battle scene once we hit the monster. And then we'll have a little fight interface. So let's go ahead and work up a little fight interface and get that all in here as well. This out of the way. So that's basically what we need to do. We need to take this move player on map and see if it overlaps a monster. So at the end here, well, yeah, we have a check to see if they moved into a wall, and that's all well and good. But let's also do a check to see if they moved onto a capital M. And if they did, they moved onto a capital M. Let's go enter fight sequence. And this is going to take a player, reference, and a monster. Well, we only have one monster, so we just need to bring in this player 1. We need to know who's fighting. But the way our game is currently designed, there's only going to be one monster ever, and that is going to be this current fightable monster. Let's move this way up. So now we got to think about the order of all this stuff. Let's see, these ones can be at the top. Actually, you know, we're just going to make a header at this point. Let's just add a header to RPG prototype just to get rid of some of this stuff. Yeah, we'll just call it, let's call it, I was thinking PCH, but yeah, whatever. We'll call it PCH for now. Just some pre-compiled stuff. And let's just move some of this stuff out of the way, like this character map, put it here. Just to help clean things up so we have more room to work with our main. Basically all these definitions, let's just put in this PCH. And we can probably put in any of these forwarding things too. And now we can just include PCH here. Now we should probably have an associated.cpp for that. I guess we will. Yeah, let's just do it. Just include. Okay, that way it has an area to compile into. And we need to make this enter fight sequence, void enter fight sequence. And it's going to be about the same. It takes a player. Now we already know we're going to be fighting the monster, and the monster's global, so let's just move that up here so everything already knows about what it is. Well, I guess it doesn't necessarily need to be here because it's in the PCH. Let's put it above the main after all. I think, you know, the current monster though, this here, it needs to be above fight sequence so it knows what it is. So that's a thing. So yeah, we'll just put them both at the top. That's fine. It looks a little weird maybe, but it gets the point across. We got any more definitions? We got this fightable. Let's put that in the PCH too. There we go. So now here we've got just our functions. Yeah. And they enter fight sequence. They move on an M. And then we do want to, yeah, so we still want to continue to update after they move on to an M. So no return necessary here. But now we need to think about the fight sequence. And we don't want to display the map here. We want to do something different. So we'll still do a clear screen, just like we do with this show map. But now we're going to actually display some player stuff. So we've got to think about how we want to do this. And we probably want a while loop here. So while player1.us.hp or get HP is greater than 0, and we want current monster. We'll probably want to do a null check on the current monster, if not current monster, just to make sure there's actually a monster. Probably just want to do that since we're not passing him in here. The passing by reference on the player assumes that it's got to be instantiated and that the error check is somewhere else to make sure it's not null. But just the way it's designed with a single monster at a time, like an arena, is going to be a little different. So, and current monster HP greater than 0. So as long as they both have HP, basically, we're going to continue on this while loop, which is just going to do some battle stuff. Okay, we need to do get current on this HP. So as long as the, yeah, it's a little different on how they're designed, but it works. It's hacky. If I were taking this more seriously and long term, I'd probably make it, you know, a little better, but it's fine. Monsters and players are just different. They have different functions. Okay, so as long as they exist, we clear the screen and let's display interface. Display fight interface, which of course right now it's just going to be some battle systems. Let's make a, I don't know, make like a P versus M thing going on here. Let's just make it like a chart. It's going to look a little weird, but it'll make more sense as we go. You'll see what I mean. I think I just want to do the player stuff on the left, monster stuff on the right, because, you know, we don't have graphics going on. So we'll just do like, yeah, something like this. It might be better to do this with a print format. Honestly, this is just going to look kind of weird. Let's see how. Well, we can still do it, but basically we want to display their HP. So let's just go like this, actually. Trying to think how to do this exactly. I think we'll just have the player kind of go first and do some attacks. Now, the player doesn't have any gear. They're just going to be wearing nothing at the start, so maybe we should give them some basic gear using our equip and create item methods. But, you know, this is going to take a while to sort all that out. So this is like potentially a day-long project of just sorting all this out. But it's going to be a nice little text-based arena fight. Okay, so let's go ahead and just get current HP out of max. Okay, so we got to think about how many lines this takes up if we're going to try to align this. This is why this would probably be better as a print format, because we got about this many characters to work with the player, and then we want to break it to the monster side. So yeah, we just need to consider that, and it's just going to look awkward, but once we write this once, we shouldn't have to write it again. It's probably going to look about like that. Let's see, how many characters is this? Let's just put that many right here. Get rid of this versus. And we basically want to do the monsters HP here too. And we are just going to go into the longest line ever. Because who cares, right? Who cares if it's a really long line? It's going to be get max. And then a new line at the end. So that should at least display their HP on that line. And then we just need some attacks. So everything just auto hits right now and doesn't really calculate with armor, but we could add all that in how we want. But really we just need to take an action basically. So we'll say like A is attack, D, I don't know what else we got. I don't know, let's just start out with attack. There's not really a whole lot else to do here. So then we'll just take CN, just take an action here. I guess we want get character in this case. Action equals get char. Could take a number like we did with the other ones. While action is not equal to A, I guess. Yeah, because there's only one action right now, so let's just make sure they chose the attack action basically to give them. We'll just give them the illusion that they have a choice, although they don't. Maybe we'll program in more stuff later, but for now, we'll just be like this. Okay, we'll just start it out as a 1, so that it definitely goes into this while loop, but this just makes sure they actually chose action, basically, just to give it a little advanced stuff. And then, let's see, what do we want to do if they chose attack? We want to get their damage and take it off the current monster's HP. So we could just go current monster HP dot deuce current by player1 dot us dot get damage, or is it attack? I forget. Yeah, I think we just call it attack. Melee attack. That should return the damage it does. It's a function that returns the damage it does. Okay. And then we'll do the same thing for the player, but only if the monster is still alive. So maybe we actually want like an is alive function. So we could just take this fightable and just go bull is alive. And we can just return monster dot HP get current greater than 0. So if their HP is greater than 0, they're alive. It's not going to return false. So that'll just give us a little helper function there. So we can just go like so is alive. Things to make it read better. Typically want it to read as nice as possible in the main loop of your stuff. So we could fix it up in more areas, but we don't want to get too far ahead of ourselves. So if the monster is alive, we'll just have it attack by just going player1 dot reduce. Player1 dot, what is it? Get. Oh, it's yeah. Let's use the right functions. Take damage, I believe. And then we just want the current monster attack. And there we go. We don't have any armor logic going on there, although we do need that, obviously, for it to work with the equipment system. But I think we're getting to the point where we've done nearly enough for one episode, so we're going to kind of just wrap it up, and we'll expand on this little RPG prototype later. And there we go. We'll just continue that loop until someone is at 0 HP. I guess for this one, we can now just check is alive. Probably want the same thing for the player. So we could do that. Just go into this player here. Also make an is alive function. We'll just copy this actually and just do like the exact same thing. Except of course it's going to be now us dot HP, or what do we have? Oh, it's get current HP. It's greater than 0. Okay. So similar function there. That way we can just quickly check with something that is easier to read. Very nice. And then we just want to check at the end who won the battle. And we'll say like if player 1 dot is alive, we could say something like, see how you won versus the monster. Then we could give them some XP. So we'll just, I guess we'll just make it literal here and gain some amount of XP, or we'll just say XP gained. And we need to get the XP of that monster. Current monster dot XP worth, or I guess it's a pointer here, XP worth, and we'll make that new line. Let's keep it prettyfied as much as possible here since it's our interface. And let's give the player that XP. Player 1 gain XP, and we need this XP worth to pass into there. Okay. And then we could stop it here, or we could do an else. And the only other case is that the monster is alive and that the player died. I guess we don't have that check here. Current monster is alive. Place take damage. Yeah, we do have the check here. So we would just say something like you were defeated by the monster. And then we could essentially end the game from there. Maybe we could do it by this fight sequence. Returns true on win, false otherwise. Because if you lose a battle, you essentially lose the game. So we can go return true on this is alive, return false on this one. And there we go. Now we got a system where we can actually win or lose. And we probably want to have that somewhere else. We could also just leave this as a... Nah, I don't want to have to keep forwarding this Boolean, so let's do it a different way. Basically, let's check the player's HP all the time. So maybe after every fight sequence here. Yeah, basically after a fight sequence or after a move, we'll just check that they're HP or that they're alive. If not, we can assume they died. So that would be essentially be right here after move. Yeah, it would be after move. Character, we could just go if, because they could get into a fight on this move basically before this show map. So we just want to check that. We call them in this case main character. Main character dot is, yeah, they're alive. We want to show the map. Otherwise, you know, if they're not alive, we want that message to hang there for a second. So let's just say cn.get. Yeah, let's just do this. And we'll just do like a press any key to continue. Press enter to quit. Yeah, we'll just say quit. You have to rerun the program if you lose. Sure. We could have it go back to a main menu, but yeah, let's just do quit for now. Okay, so we got a little system here. Got a little system to fight the first monster, and basically what we want to do after that is we want to make a new monster. So within this big while loop, we want to set up a new monster if they won the fight and put it on the map. So let's go ahead and run what we got. The game's essentially going to give you nothing left to do. Okay, we got a link issue here. Something with moving everything into the header. The map already defined. Okay, gotcha. So, yeah, we got this. Let's get rid of this other PCH. Let's go ahead and remove this. It's just giving us multiple defines. Having only one CP will be better. Okay, let's make us a warrior. And apparently we have it messed up. Check. We are not on top of the monster, but it decided we're going to fight it anyway. So let's just check that out. Oh, it should be equals, not equals. We were just always entering the fight. So let's fix that real quick. Okay, let's make us a warrior this time. Let's move down to that monster and battle. Monster's only got 3 HP. Let's make an attack. We did 1 damage. We took 1 damage. Same thing. Boom. We defeated him. We should have got the message to say... Okay. So, yeah, a little error here. We need this message to be on the end of the battle. Press enter. So we want to press enter at the end of the battle. You can continue or something, you know, like that. Okay, and let's put this back in that battle right here. This way it'll stop us basically at the end of the fight. This while loop only goes till while we're fighting. Once we're done fighting, we got this end sequence right here. But we want these messages to hang for a minute so you can actually see what you've got, or what happened. And that'll be right here. We want them, if it's alive, to continue. Else we want to do break, which is going to break out of the while. So if we died, if we're not alive, it's going to break out of this while loop, this while running. Or, you know, other than break, we could say running is false. Because we are controlling it with that loop. We could do, you know, if we don't care about this Boolean too much, just an optional way of doing infinite while loops. We could get rid of this running altogether. Let's just do it this way, because trying to design it in this way where we don't care about this. We could instead do the spider while loop. I call it spider because it looks like a spider face. You go 4 and you make a spider. You see the spider there? This is just an infinite for loop. It's the same as an infinite while loop. Another way of doing this is you can just go like while 1, but essentially the only way to get out of these infinite loops is with a break statement. And we have one right here, so that'll break out of it. So any of those work. If you want to stick with the Boolean of running like we had it before, that's fine too. I guess I'll just show you those a little bit of C++ knowledge there. But the way we're designing it, where the only way out is to literally get killed, it's going to be like a battle arena kind of thing. Alright, there we go. Let's fight this monster. Attack, attack, we won. Now it still didn't... Yeah, we can't leave until we die, basically. Now it still didn't show the message, so we want to analyze what is going on here. And if we look at this closely, press enter to continue, you know, we should have got all these messages, and we probably did. It just didn't seem to care, or this get probably had a return still in the system from when we were pressing get care over here. So we probably want to do like a, I don't know, something to clear the string, basically. I don't know what's going on right there, actually. This should stop. This should stop everything, but for some reason it's not. Let's just put a breakpoint right here and see what's happening. Sometimes the CN requires some really careful analysis to get it sorted out. Attack, attack, there we go. But the only reason it's stopping here is because of this breakpoint. without this breakpoint, I don't think it's actually stopping. So let's give it a few more tests. Move on top of the monster. Fight it. Oops, I pressed stuff literally too fast. Start it over again. Oops. Okay, let's slow it down once we get into this battle. Attack, attack. Yeah, it flashed on the screen super quick, but it's just flipping right through this. And it's probably because the stream is not clear. So let's see if we go cn.ignore 100 or a new line. I think we just need to eat that new line. So let's just try it like that, because I think it's still got this new line in the stream where we hit A and then enter on the attack. But cn is like that. It doesn't actually eat that new line from where you last pressed it. It's like we got to attack 4 times. There we go. Yeah. So with eating that previous new line from the last attack, seems to be okay. You won versus the monster, gain 14 XP. Press enter to continue. Very good. And basically what we want to do at this point, let's just make this sort of a complete loop. Let's count how many monsters you defeat and instantiate a new one. So let's just go int monsters defeated, oops, defaulted, defeated equals 0. And anytime you win a fight here, let's just go monsters defeated plus plus. It doesn't seem to know about this. Yeah, it does. Just hasn't decided that it knows what it is yet. Lies and treachery. All right. Yeah, it knows what it is. Unless we spelled it wrong. Yeah, we spelled it wrong. All right, and then at the end, we can say, okay, out monsters defeated. And we can, you know, kind of have a little system where we can challenge our friends and say, how many monsters can you beat? What class? I don't know. Just a little something to actually have a bit of a score or a goal to go for. That way, once we build up this game a little more, we can have like a, you know, a ranking system type thing. And we actually got a little bit of a playable game. Is it fun or not? Don't care at this point. Well, currently now, not really. But it'll get more fun as we start dropping gear and allowing you to gear up. And if you want to put, if you want to use some library to make visuals for the game and make it not just a console game, then so be it. But the main thing we want to do is we actually want to put these systems that we built to use as an actual example. So that's the real goal here. All right, so let's just do one last thing, and let's go ahead and make a create monster system, because right now, create monster, right now there's only one. And it doesn't really care about much. So yep, let's go ahead and do this. We'll make this just return the current monster pointer. So it's going to be a little bit like our create item system, and we'll just go create underscore monster. You know, let's actually make this return nothing. All right, and let's pass it a pointer to the current monster. And it's going to be an n, non-const, because we need to modify it. If it is equal to something, let's go ahead and delete it. So if it is already a monster, we want to clean it up and get rid of it. All right, because we're making a new one. It's actually, I guess, going to be an in out. It's going to be both an input and an output, which is a little weird, not typically recommended, but for this system, it's basically a factory, so, and we're reusing the same monster, so this will work just fine. And new fightable, and we want to give it some random stuff. This is its HP, and we probably want its HP to be like the main, based off the main character's stuff. So we probably want to pass it the main character stuff. So let's just go player star. We'll call this base calc. We're going to base how strong the monster is off the player's data. So we'll pass in a pointer to a player. It's got to be const, and we'll just say if base calc. If it's null, we'll just return, I don't know, you know. Not a good scenario, basically. With it, we don't want it to be null. So we'll have to maybe check that it actually creates something. Because really, in reality, we probably want to throw or crash or return something that says that we messed up in this whole calculation, or this whole create monster function. But basically, we don't want to be calling any of these base calcs things if it's null. So let's just base this off the level. Or let's base the HP off of, what do we want to base the HP off of? Maybe like half of the player's HP or something. We just want it to be somewhere around half because we don't want it to be as strong. So let's just go lowest HP equals, I don't know, what's its lowest HP going to possibly be? Maybe the player's current level or current HP. I don't know how we could do this. Kind of want to go off player level. I feel like that makes sense. Yeah, I don't know. We just need to come up with something basically. So let's just get level times it by 2. And max HP, let's get their level times, let's times it by like 8. Let's make them potentially have a lot of HP. And then we can make this first one lowest HP, max HP. Oh, then we gotta go random namespace here. Now this takes unsigned ints, but it's gonna cast those automatically. We should probably be using more static casts, but I'm kind of just not worrying about it if I know it's gonna work. Now we want its damage here. So we probably need to come up with some damage systems here too. Let's just use something similar to this. Level thing. Lowest dam to max dam. Sure, we'll do a very similar system. Say the minimum is the level, maximum will be times 4. Maybe times 2. We'll start hitting harder and harder. But the thing is, our players aren't really going to have an easy way of healing. So this is actually going to be quite problematic for them in the long run, probably. And it's not really randomized. It's going to scale pretty directly. Whereas the monster's HP is going to be random, but the lowest and maximum damage is just going to be directly input based on the character's level. So it's going to be predictable after a while. So someone that plays the game a lot will notice that the damage the monsters do is pretty predictable, whereas their HP is going to be less predictable because of this randomization. So I don't know, designed as intended, sure, that's fine. And we should be able to take it from here. This in out should be updated, and that should be it for this function. It's just going to be based off of that. So we do need to make sure we create the player before we create any monsters. So let's go back down to our main and see where we got this. Yeah, we got our main character set up. We got our monster set up. We need a location. So let's, we no longer want to do this. We now want to go create monster, basically. Let's see, it's create monster, pass in current monster. Yeah, and we also want to pass in main character, and that should handle everything. Yeah, we also need to give it an X pause and a Y pause, so let's go ahead and that. In that same function, the create monster function. And we probably just want to random it. Yeah, let's do that. But we want to make sure it doesn't place on top of the player, but basically it's going to be from 1 to 12 on either of these. Maybe it's 1 to 11 on the Y pause, I think, because 12 is a wall. 12 is a wall. And we want to do this. We want to just check that they're not on top of a player. So, yeah, let's just check that it's not. While the map at the current monster's position, X pause and Y pause is not equal to the player's location. Or, yeah, let's just do it like this. So basically, if they end up on top of the player, we give them a new position. And that's it. And eventually they'll not be on top of the player, so it'll be fine. We should probably put in here an OR to make sure they're not on top of a wall as well. Because who knows, we might have more walls later, or, you know, we might have some pathfinding stuff going on. Let's just make this one giant line. Basically, we want to make sure their current position is not on top of the player or the wall. Otherwise, we're going to generate it again. Make sure that's not on top of one of those, and that should give them a valid position somewhere on the map. And then anytime we create one, we want to update the map with these locations and then show the map. So we essentially need to also do this sort of thing. Now we know when the player moves on top of a monster, they fight it and that M will go away. So we only really need to update the map M after we create it, which we could just do right here at the end of create monster, because monsters can't move yet. Well, we don't really need to worry about that. Now let's check out this fight method one last time and get that sorted out. Where's the fight? Okay, that's on the move. Player moves. If they end up fighting, and if they end up winning, let's create another one after they defeat the old one. So we'll just go create monster, current monster. And that should handle everything we need. And it needs the player for the base calc. They will have gained XP, and if they got a level, then it's going to be different. Is this one again? Player 1. We need to dereference it because it's pointer to it in that case. It's a const pointer, so they can't change it. But yeah, if they killed the monster, we make a new monster and place it randomly on the map, and it should continue from there. And this should essentially let us keep playing. All right, so let's go ahead and see how many monsters we can defeat. What do we got here? Current monster was null point. Okay, we got a little bit of a bug here. Oh, it's this in out. Just got to change all these. Now we should be passing in create monster with current monster, right? Yeah. Okay, let's try this again. Still getting a null pointer issue here. Oh, it's right here. This in out should be the same thing as current monster. So in my thoughts, I was thinking that this actually shouldn't be. Well, let's see what happens here. We might have a bit of a logical error. Yeah, so this is not updating as we think. I think we need to pass it a reference to the pointer. Yeah, because if we pass it a reference to the pointer, it can edit the actual correct pointer. All right. So that's a bit of a conundrum. And it's still complaining about the same thing here. So we got to analyze actually how this is messing with the memory here, because it's not exactly doing what we think. We are passing it into create monster, but it is creating a copy of the pointer. So we probably want a reference to the pointer. Yeah, we want a reference to the pointer here. Let's see if that works as expected. That way it doesn't, yeah, that's better. Looks like it randomly placed it right beside us. Let's move up, over, and we're battling. Attack, attack, attack. We only do 1 damage, so we don't have gear. 1 versus the monster, gain 16 XP. Continue. New monster's down there. Let's go fight him. Our HP is lower, but we can battle. It's got 8 hit points this time. We won, gained 22 XP. Alright, let's see if we can defeat a 3rd monster. We only got 3 HP left. No, we got defeated this time. Oh, and it broke out a little before we could see our final numbers. So I guess maybe we actually want just a final get care here to stop it from closing that. Let's go ahead and move on top of the monster. Battle. This one's got a lot of HP, so we're going to get our butt kicked. This one has less. Fight this one. Oh, this one. Okay, this one's going to kill us. Yeah, this one was hitting too hard. So this one was hitting for more than 1. Total monsters defeated. 3. Cool. So it looks like with this system, with only doing basic attacks that do 1 damage, we can defeat about 3 monsters if we're lucky. And it's probably going to stay that way. But once we get to putting on equipment and using weapons and healing with potions and monsters dropping stuff, you can see how this would be a more fully fledged system that could actually be a bit of a varying challenge and require skill and luck more than it does now. But I think that's enough for this episode. Just wanted to get a sample of it working in some sort of system without pulling in more libraries. And, well, here's a system, and it seems to work for now. Hopefully you learned some stuff. I guess the most critical thing to understand, basically, for C++ wise, is understanding how this create monster works once again. Some more pointer knowledge and reference pointer type stuff. We did run into a quick issue there. But yeah, basically, if you're not pulling it in by reference, it's making a copy. So doing it by a reference to the pointer pulls in the actual pointer, so we update the real one. And yeah, that takes care of it. All right, well, thanks for watching. Okay, I guess I'll say one last thing. If we're doing it like this, basically what we would have to do is we would have to, at the end here, well, we got all these in outs, so we would have to say current monster equals in out. Because this in out copy is going out of scope, and we want to set the current monster pointer to it before it goes out of scope. So this should actually work and not have any null problems, because data should be there. Let's just check. Yeah, so that would have been another way we could have fixed the same problem. The battle. So maybe next episode we'll actually design ways to mess with equipment a little bit and design ways to just use more things other than just your basic attack. So we'll flesh out the battle system a little more, get the arena going a little more. And you know, this is just we're just making it a basic little battle arena because it's simple, but in reality you could do anything. You could make it so you walk between different maps. You can probably imagine how to do that. Just walking between different maps, run into different NPCs that do different things, and you could essentially use these systems as you go. And that's the whole point, and hopefully you're learning stuff. See you in the next episode. Peace out.